let's pause that. Alright then, welcome back. We're going to be doing some vectors practice in this video. Just going to go through everything that we've learned in AS vectors and just tie it all together in a neat little knot and say we've done it. So let's get started. I'm pretty sure it's meant to be SE at the end of this kind of practice, but I'm just ignoring that because I want to focus on the maths right now. All of the words that I actually use will be correct, which are mathematical. The mathematical words like collinear. Oh, that's a good one. So, here's what you are expected to have learned by the end of AS level vectors. This is for AQA, but it's pretty much the same across the board in any A level. How to write vectors, finding magnitude and direction vectors, adding and subtracting vectors and multiplying by scalars, we did all that. Recognizing when vectors are parallel, we did that. Unit vectors, we did that. Position and displacements. And then geometrical figures, we did that with parallelograms and rhombuses. So to get started, we'll have this nice simple question. Draw these two vectors. Now the video seems a little bit overexposed, but I'll just say what they are anyway, so you'll know. I'll get it stuck on the board. Okay then, this question is to draw two vectors. Our first vector is 3i plus 2j. Right, now I don't actually have a grid on this board, but we'll try and do it best. So 3i means 3 across. Let's just say 1, 2, 3, and then 2j is 2 up. There's A. B is a column vector, it's -7, 7, so it goes, x component is -7, so it's going to go, I'll do it over here. If that's the origin, that's the new origin. 1, 2, 3, 4, 5, 6, 7, then it goes up 7. And my question's in the way. Didn't think this through, did you? So this is going -7 up 7. So it goes that way. You have to write your direction on it and then label it B with an underlining, A with an underlining. That's question 1, and that is done. Let's move on to question 2. So the red ones are quite simple ones in this video. This one is find the magnitude and direction from question 1. We have to find the magnitude and direction of them. Let's get it stuck on. So to find the magnitude, what we need to do is do Pythagoras. So we're going to do Pythagoras of both. Let's start by looking at A. A is going to be each component 3 squared plus 2 squared, all square rooted. We've not got a plus and minus in front of it because the magnitude is always positive. This is 9, that's 4, so it's root 13. Okay, nice one. Now how about B? This is 7 and 7, so we've got -7 squared. So we've got root 98. Root 13, because it's 9 plus 4, and then root 98. Can we write root 98 a little bit better? Well, it's 49 times 2, which is 7 root 2. Okay, so we've got the magnitude of each of these, now we need to do the direction. Without it specifying what we're doing in the direction to, we're just going to take it as the I. The direction of I. So we're going to do an angle from there up. Here, it's this angle here, theta. So what we want to do is a bit of Pythagoras. So we're going to do tan, opposite over adjacent, the opposite is 2. That's 3. So theta of A is equal to, now this is where you need a calculator. Delete everything, delete all, yeah. we're going to be doing shift tan to the -1 bracket 2/3 30. Okay, same again now, but with tan. This one is going that way. So let's first work out this angle here. So now we're doing tan of, so that's just going to be tan to the -1 of 1. So we want to do shift tan of 1, which is 45 degrees. Makes sense, that's 45 degrees. Now, really that's that angle there. What we want to do is do the angle from there. We're looking at the one from the positive I direction, which would then be 90 plus 90 minus that. So it's going to be 135. So just remove that subscript there. This is the direction of B. Okay, so we've got that, and that, that, and that. All right, job done. Bit of a funny one, those direction ones, when they don't say what you do in the direction with respect to, but it's all just simple trigs, so just get involved. I'm slightly concerned about the exposure, but I think it's fine. Okay, next question. We've gone on to purple now, which means we're going slightly spicier. What we've got here, question 3. Given this, find A and B. So we've got this vector equation. We've got A times some vector minus 8, another vector which is 8B equals 12, 6. And we need to find that 8, no, the A and the B. Let's get stuck on. Let's just slow down a bit, because now it's getting a little bit more tricky. We have to actually think, what does it want us to do? What it wants us to do is solve this vector equation, which means finding these two variables, A and B. That's what we want to find. So at the end of this, we're meant to get two scalars. And we get them by looking at this equation. What kind of stuff might happen in that equation? Well, we have to make all of the elements of the vector on the left equal to the elements of the vector on the right. So probably simultaneous equations. So let's get involved. We need to do some vector algebra. So let's just draw a line. We're going to multiply out this A. So we get, okay, and now we're going to minus these two vectors. So on the top we've got 5A minus 8. And the thing is that this all has to be equal. The element on the top has to equal the element on the top on the right hand side. Likewise for the element on the bottom. So we get two simultaneous equations. I could do with a better chalk colour. Blue, is that any good? Oh, that's nice. No messing, this is quite easy. We're going to add the 8 over, that gets 20, so A is 4. Bottom is, but then if we've got A equals 4, this is 12. So then we've got B equals 6. These are our answers. 12 minus 6 is 6. Sweet, job done. This was right and that was right. Got one more, medium spice. So question 4. Given that P and Q are parallel, find X when P equals that and Q equals that. So P and Q are typical kind of letters for vectors, and they're both given as column vectors. So what is it actually testing us here? What does it want us to do? What mathematical skills does it want us to use? Have a think whilst I've got this on. Divide it off. Okay, did you think about what skills? Did you think perhaps we need to use the fact that if these two are parallel, then they are scalar multiple of each other? Now I'll write this down. That's the fact that we went through in the second video on vectors. So all we're going to do is we're going to plop all these in. So P minus 3/8. K, we don't know what this K is, but the thing is we need to find one that makes it work. And then we're going to put Q in. So Q is in terms of the variable X. So X is something that we need to find out, but it looks like we might have to find out K at the same time, because we need a K that makes them parallel, and that's going to force X to be some number as well. Like, just bear with us. Let's check it out. So just like before, I'm going to multiply out that K. Have I got enough room to squeeze it on the right? Yeah, I do. So our vector on the right hand side becomes 6K on the top and XK on the bottom. So now we've got simultaneous equations. Tell you what, this is doing my head in. I need to fix that. This one, obviously that means that take the 6 over to the other side, so it's going to go underneath, and then you're going to get minus a half. So this implies K equals minus half. The other simultaneous equation, 8 equals Kx, but we know that K is now minus half, so we're going to plop that in. Well, because K has to be that to make them parallel on the top. What's that noise? Hold on.
Oh, shit.
Got a parcel. Jesus Christ, the delivery woman like proper just jumps out on me. And I've lost my chalk. Or anything, any sense of rhythm. Right, let's use this tiny piece of chalk. So we've got K is equal to minus a half. We're just going to plop that in. So we've got 8 equals minus a half X. We could write that as minus X over 2. Same thing. I mean, like, you know, you could just... Same thing. It's up to you. Whatever you want to do. I'm just going to do it like this. So we're going to times something by minus half and get 8. So it's going to be minus 16. Because we times that 2 out and then move the minus sign over. That, I don't have any red chalk, but that is the final answer for this one. So just like we thought, what are we going to have to get? X is the variable. On the way, we've had to find the value of K, which makes it parallel. Now, I've got 2 extra spicy ones to finish with. So I'm going to have to get rid of all of this. So, blue is our extra spicy one right now. The exposure is mad. Look at that. Okay, we've got find the unit vectors of these 2 vectors. Now, a unit vector is something, remember this, when the magnitude is 1. It's a unit. So these 2 vectors, it's unlikely that their magnitude is 1, but we want to find a unit vector which is in that direction. So we need to find the magnitude of these and then just divide each component by that magnitude. What that means is that the end vector will just be magnitude 1 and in the same direction. So, step 1, find the magnitude. Now, the reason why this is extra spicy is because we've got a lot of trig here. Now, what you need to be thinking of is what kind of maths does it want you to do? If it just wanted you to do magnitude and then divide by, that's not that spicy, is it? So what you need to think is there's trig there. It's probably going to want to test me of something to do with trig. To find a magnitude, you have to square things. So if we're going to square some trig things, then you're going to be working with like cosine squared and sine squared. Whenever I see cosine squared and sine squared, I start thinking of the trig identity. So to get started, I'm going to write that down. That's our trig identity. So what we're going to do is I'm going to look at A first. Magnitude of A. This is in alpha, by the way. And rather than doing a big square root, I'm just going to go to index notation to the power of a half. Now I need to expand this out, so I need to square this. So if we're going to square all of r cosine alpha, we're going to get r squared cosine squared alpha. What that looks like is Remember, the square is just after the S1 cosine. It doesn't mean you're doing the cosine twice, it just means you're doing cos alpha times cos alpha. Let's get some better chalk. Okay, common factor of r squared. Let's pull that r squared out. It's still to the power of a half, but then we've got this. What you'll notice from here is, even though I've written it the wrong way around, well, different way around, we've got cosine squared add a sine squared. Well, all of that equals is 1. So this just becomes r squared to the power of a half, which is just r. So if we want a unit vector in the direction of A, what we need to do is divide A by this. So unit vector, and it's just going to cancel those r's out. And that's it. So now we're going to move on to B, but B is a little bit more... We'll be able to squeeze it in, but it's a little bit more unusual. Now we've got tan, so let's think, we had to use an identity there, might we need an identity here? What is tan? Well, tan is sine over cos, so let's just get involved. Now this is the bit, right, where you go, right, what do I do with that? We had to use an identity before to simplify it, so let's just think, we did that before, let's try that again. Now, this doesn't have any tans in it, but what we could do to force there to be a tan in it is divide it by cosine squared. Because if this is, we could just square that and square everything on the right hand side, and that's still true. So what we could do here, if we divided all of that by cosine squared theta, and then that by cosine squared theta, that's okay to do because we've done same thing on the left of the equation and the same thing on the right of the equation. What happens here is this breaks up. You get cos squared alpha there, theta, and a cos squared theta here. That goes to 1, and this goes to tan. So what you get is another identity, which is tan squared theta plus 1 equals 1 over cos squared. So all of this becomes that. So now we need to get the unit vector in the direction of B, so we need to divide by that. If we divide them by a fraction, you flip it upside down. So we're actually going to times by cosine squared. That should be a beta. You know, when you're writing this really quickly, it's really easy to write a line under there because you think you're doing a fraction, but you're doing a vector. So, right, let's not stop there. Let's just keep going and multiply that out. Right, we could stop there. We could get our red chalk and say, yeah, that was right, and then say that about that, but I don't feel happy stopping there. You see here, if we were timesing tan by cos, we're actually timesing sine over cos by cos, which means it's just sine. So I want to simplify stuff as much as possible. And that's your final answer there. Nice and clear. That was a bit of a spicy one. We've got one more left. I don't know how far we are in this video, but I do recommend taking regular breaks. There's a thing that I genuinely do, and I've made a video about it called Pomodoro. I time myself for like 25 minutes or half an hour, take a little break. On my desk I've actually got this. It's a 30-minute egg timer. It's obviously just it's a desk decoration, but also it's 30 minutes. It's just a little bit nicer than having your phone out and timing things. It's just a bit more connected, you know, like a bit more I can't think of a word for it. Gonna have to get rid of all of this for our spicy, red hot final question. This is our final question, question 6. What we've got is A, B, C, D, and they are coordinates. They have position vectors A, B, C, and D. And each of those coordinates have midpoints M, N, P, and Q. Now, I've got a diagram to go with this. Here's the diagram. We've got some kind of shape, it looks like that, A, B, C, D, M, N, P, Q as the midpoints. Let's get that on there as well. Now for the actual question. That's our information. Question is, express MN and PQ in terms of A, B, C, and D. We don't have to use all A, B, C, and D. Probably not, but we just have to, we've got no numbers. We're actually doing maths without numbers, which is the typical thing that people say, like, how's that maths? There's no numbers anyway. So, what I like to do before I do any question is really kind of break it down a little bit and say, what does it want me to do? So we need to find two position vectors. M to N, direction is M to N, and then P to Q. How are we going to find those? Well, we have to do it in terms of A, B, C, and D. What we could do is we could write on A, B, C, and D, but we don't know where the origin is. We could just say, let's pretend the origin's here. A, B, C, D. And then that might be a little bit easier. Or we could just go all in. So the information that it's testing us is, do we know what a midpoint is? Now, we did this last video. It's like the midpoint of a coordinate. It's just the midpoint, the vector to a midpoint, displacement vector to a position vector to a midpoint is, now this is the midpoint between A and B, and the direction vector to that, or position vector, get them all mixed up, to M, is this. All right, that's a good start, because what we need to find is Mn. Now, what is Mn in terms of its position vectors of M and N? Well, it's going from M to N, so we need to go from M down to the origin, then up to N. So that's going to be, oh, that's what it always is. So let's go through this and find the solution. We know that OM is this, but what's ON? So ON is the midpoint between B and C. So we're going to just plop that in there. If it's the midpoint between B and C, we're just going to put B and C in here. So now we've got enough information to find what MN is. ON minus OM. Common factor of a half, we could take that out and do a little bit of algebra, or we could expand it and then take it back out. Let's imagine we took the half out of everything. Then we've got B plus C minus A minus B. So the B's would cancel, and you get left with that. Okay, let's move on to looking at PQ. We need to do PQ now. So PQ, same as here. What's OQ and OP? That's between A and D. P is between C and D. So then PQ lovely, these are our answers. PQ, MN. Now let's do it underlined in red, because I know they're right. Because I'm right. Now, it makes sense that they're actually the same thing, but with a minus sign different. You see, this is C minus A, and this is A minus C. It's just the same thing, but a minus sign different. Now, if we look at this, that's going that way, this one's going that way. So that kind of makes sense. So we're done there. But let's see what the next question is. Final thing. Question B is describe the quadrilateral MNPQ. So we've got MNPQ. That's the quadrilateral that we're now looking at. Remember when I said in the previous video, if you're doing anything where it's describe the quadrilateral, all that means is it a parallelogram or a rhombus? That's all we're going to do. So to do this, we need to think, what does it mean for it to be a rhombus? Okay, no, parallelogram. We're going to start with a parallelogram. What we need is the vector along the top to be equal to the vector on the bottom. Well, we've done that. But now we need to work out MQ and NP. So let's just write the summary of what we did in part A. So it's equal to minus A. Now, I'm saying that's okay because we know that this is going in the wrong direction, so that's cool. That's all good. We could swap it and say it's that. That's fine. Now, are we still recording? Yes, we are. Now we need to look at M to Q and N to P. So we need to work out those. I'm going to try and cheat a little bit. Instead, we could go through all of this, but notice how this is A minus C when it's going from P to that. And this is M to N, and that's C minus A. So what I'm going to say, I'm going to guess that this one, M to Q, is B, no, D minus B. Because it follows the same kind of rule, D minus B. Now I don't feel entirely confident about that shorthand, so let's just do a quick check of it. If we're working out MQ, it's OQ minus OM, right? OQ, we've done it before, is A plus D. And then we've got OM somewhere. I think I rubbed out OM, but this is it, A plus B. Now C, what would happen? We would get A's would cancel and we get D minus B. So yeah, so that looks good. So we know that's right, but we still need to check, is it the same as NP? So NP is OP minus ON. We've got this from here. OP is C plus D, then we're minusing ON, which is this one. So we're going to get C's cancelling and it's going to be D minus B. Good, we've used our previous result. Usually in B questions we use our previous result, so I'm happy at that. So notice MQ is the same as NP. So we know it's a parallelogram, but the final thing is it a rhombus? Now we need to check if it's a rhombus because we know it's a parallelogram, but that parallelogram could be a rhombus, and so to check if it's a rhombus, we need to find out if this vector is the same as this vector, just two corners. So I'm choosing NP and QP. NP and PQ. So that's what I'm checking, that's why I've written it with a question mark on top. Nice, we're doing magnitude, so I've not got the vector lines, we've got not got the magnitude lines because we're doing displacement vectors. That's fine, that's all fine. So we need to do a bit of Pythag, okay? How can we do Pythagoras on this? NP is here. Now we're at this stage, right, where to do Pythagoras, you do the x component squared plus the y component squared. You see, all we've got is d's and b's and a's and c's. We don't know what the y component is or what the x component is. So we can't actually check. We can't do Pythag of a vector where we don't know its components at all. So we can't check if it's a rhombus, so we're just going to stop and say it's definitely a parallelogram. And that is it. That is the full spice going on here. I am happy at that. Okay, so this is vectors all done and dusted. What we're moving on to next is introduction to kinematics. Kinematics is all, I've got a wet moustache. Kinematics is all about the kind of looking at how things move. You might have studied it in physics if you're doing physics A level, or you might have done some of it in physics GCSE. But we're looking at a mathematical point of view, so I like mathematics. I think it makes much more sense to look at it from the mathematical side. At university I did a degree in maths and physics, so I often looked at the same thing from maths and then physics, and the maths side was a bit more elegant. It made much more sense, whereas this was a bit more of a leap of faith. So this is good, this side. This side is it's good. It's good. Okay. I'm going to open my parcel and I'll see you next time.